Today we're going to work on measuring segments using the segment addition postulate. So in order for us to find the distance between 2 points, we have to take point A and point B and find the absolute value of the difference of their coordinates. Coordinate B is 6 and coordinate A is -2. So in order to find the distance between those 2 points, we can either count, or the distance between B and A is equal to the absolute value of 6 minus -2, which is the absolute value of 8, which gives us 8. But we could also write the point A first and B second. So the absolute value of -2 minus 6 is equal to -8, and the absolute value of -8 is 8. The distance from 0 to 8 and -8 is the same, which is 8 units. Now we want to find the length of each segment, starting off with the length of segment MN. So the length of segment MN is equal to 11 minus -20, and then we want to take the absolute value of that difference, which gives us 11 plus 20, which is 31, and the absolute value of 31 is 31. So the length of segment MN is 31 units long. Now we want to find the length of segment XY. So the length of segment XY is equal to the absolute value of 51 minus 33. And so we need to go ahead and find the difference between 51 and 33, which will give us 18. And the absolute value of 18 is 18. So therefore, the distance between X and Y, or the length of segment XY, is 18 units long. Now in geometry, sometimes you have to draw the figure and then label what you have to figure out whether you're going to add, subtract, multiply, divide, or the numbers. So we have the distance from R to S is 15 units long. The distance from S to T is 9 units long. We want to find the distance between R and T, which is including those 2 segments. So therefore, we're going to add the 2 numbers together. 15 plus 9 gives me 24. And so the length of segment RT is 24 units long. Now on the next one, we still need to label what we have to see whether you're going to add or subtract the 2 numbers. So the distance from S to T is 10 units long. The distance from R to T is 39. Notice R to T is the entire segment. That's that yellow segment. What is the distance between R and S, which is part of the segment? So since we have the whole segment and we have part of the segment, we're going to take those 2 and subtract, and we end up with 29. So the length of segment RS is 29 units long. In the diagram, the length of segment EG is 59 units long. What are the lengths of EF and FG? So first of all, we see here that the length of segment EF is 8x minus 14. The length of segment FG is 4x plus 1. We're going to use the segment addition postulate in order to figure out what the value of each segment is equal to. But first we have to form an equation and solve for x. So the length of EF, which is part of the segment, plus the length of segment FG is equal to the length of segment EG, which is the entire segment. So now we're going to substitute 8x minus 14 in the place of EF and add that to 4x plus 1, which is segment FG, and set it equal to the entire segment, which is segment EG, and it's 59 units long. Now we need to combine like terms. 8x plus 4x is 12x, and negative 14 plus 1 is negative 13. So we get 12x minus 13 is equal to 59. Add 13 to both sides. So now we're going to cancel out 0, bring down what's left. 12x is equal to 72. Divide both sides by 12. X is equal to 6. But in the problem, it is asking us to find the length of segment EF and the length of segment EFG. So therefore, we have to evaluate the expressions. The length of EF is 8x minus 14. So we're going to substitute 6 back in the place of x, multiply it by 8, which is 48, and subtract 48 by 14, and we get 34 units long. Segment FG is equal to 4x plus 1. Substitute 6 back in the place of x. 4 times 6 is 24. 24 plus 1 is 25. So if you go back and you add 34 to 25, it should equal 59. And if it is, we're right. If it's not, something went wrong in solving for x. Go back to the drawing board. In the diagram, the length of segment EF is congruent to the length of segment FG. What is x? When you think about the word congruent, it means the same length, same measure. So notice that each segment has a tick mark. Segment EF has 1 tick mark. Segment FG has 1 tick mark. So the expression that represents EF is 12x minus 1. 8x plus 11 represents FG. And since both of these segments are congruent, we say that segment EF is equal to segment FG. So substitute 12x minus 1 back in the place of EF and set it equal to the length of segment FG as the expression 8x plus 11. Now we need to subtract 8x from both sides. Cross out 0. 4x minus 1 is equal to 11. Add 1 to both sides. Cross out 0. 4x is equal to 12. Divide both sides by 4, so x is 3. Now, if you wanted to find the length of segment EF or FG, basically you just substitute 3 back in the place of x and evaluate the expression. 12 times 3 is 36. 36 minus 1 is 35. 8 times 3 is 24. 24 plus 11 is still 35. So both segments are equal to 35, which means the entire segment is 70.